Hello there, ICS3U folks. Uh, you've got a word processing document open, I hope. I'm using Smart Notebook only so I can use this thing and show you the stuff I want to show you. You can use your Google Docs or your Smart or your Word Perfect or whatever you would like to take your text notes. You could even use the Ready editor, right? This is just as good as any text editor if you wanted to. And then just save it as a text file, right? Save as a text file. So you could use that. I'm not going to do that. I'm going to delete that off. I am using Smart Notebook, and you can use Smart Notebook too, but you don't have to. Uh, Data type casting. I'm hoping that in your warm up you ran into some problems, or at least some things that made you think. The idea is when we read in stuff from the keyboard or from the file, uh, not using the console, not using HSA console, then everything comes in as a string, which is fine if you're only using strings. But as soon as you have to do some sort of calculation, like calculating how old someone is depending on what year they're born, or how much you paid for your lunches this week, or whatever, if there's a calculation, we have to have numbers. We have no, but everything gets read in as strings, so that's trouble. And so we solve that problem with using something called data type casting, or just casting usually. And so there's what I just mentioned. Basic Java input doesn't have a c.readInt like the HSA console. This was kind of cheatsy. The HSA console allowed us to read integers from the keyboard quite easily, but the good old buffered reader doesn't have a read int. It's only read line, um, and so that means everything comes in as a string. We must combine other Java functions in order to solve this problem. So we need to switch strings from that input, from keyboard or file, to integers or doubles. Remember, doubles are the Java way to say a real number. So we got to switch. We got to bring in strings that are actually string numbers, and we'll show that soon enough, and then be able to change them to numbers. The process of changing from one data type to another is called casting. This isn't got anything to do with fishing. It's got nothing to do with broken limbs. This is something else. It means changing one data type to another. We've actually already seen some casting. So for instance, and I'm going to open Ready. You don't have to necessarily have this out, but I would like you to get these examples your uh, into your note. I'm going to use the HSA console for. I don't have to. I'm going to use system.out, but I'm going to kind of go back and forth a little bit. Data type note, data type casting. Okay, and then I'm going to use system.out.println, and then 12 divided by 7. Actually, 12 divided by 7. When I print that, it'll print it out to the system console eventually here. It answers 1, right? Because 7 only goes into 1. This is integer division. But what I can do is I can cast that, and some people saw this in their slope formula question from earlier on this unit, that I can cast that and actually make it a float. If I sort of say, okay, do this calculation but make the output a float, this is a float, which is actually a decimal number that has not many digits of accuracy, and usually we use double, don't we? And why is it called double, remember? Do you remember? Oh, it's got double the digits, doesn't it? It's got double the digits. And so that casts what was originally an integer division to other other types. Notice there are other tricksy ways of doing that. For instance, if I make one of the numbers a decimal, it'll actually then know that I wanted it to be, this is a double then. And so it'll do a double division instead of a integer division. And again, this is what casting is all about. This isn't what I'm worried about though. So those examples, by the way, I got in my note. This isn't what I care about, right? I'm reading from a file or from the keyboard. I'm asking the user to put in some input, and it's coming in as strings, but I want them to be numbers. That's the issue. So what about strings? How do we change a string to an integer or a double? So this is the idea. So if stuff in is a string variable, then the casting looks like this. So this line here, by the way, right here, can I get in there? No, I can't. This line right, can I highlight it? I bet you I can highlight it. No, now it's not letting me play. Oh, no, there we go. So this line here, right there, is like we're using the buffered reader without the HSA console to read something from the keyboard. Okay, this is BR is our buffered reader. So this is stuff in is coming in as a string, and that's the only way that it will come in. But if I want to change stuff in into a double, I make a variable called price, and then this line here is my casting line. So I use this line double dot parse double. Parse is basically a computer science term for change. Change the double of stuff into a double. Right now I'm going to actually show you how that code works, not from the keyboard. No, I don't want. Yeah, no, that's the one I want. So that stuff's all going to print out. But what I'm going to do is I'm going to make a string called stuff in, and it's going to be a string that's going to have 8.234. You know, it's going to be a decimal number. But notice, since it's in quotes, this is a string. Stuff in is a string. And then I'm going to make a double called price. That declares it, right? That goes saves a spot in memory. And then I'm going to cast it. And notice that when I spell it right, it changes color, right? So ready is helping me get the right commands here. And then in brackets, I'm going to write in stuff in. Now notice that stuff in normally would be read from a buffered reader from a file or from the keyboard, right? Not using the HSA console. And so now I should have a double that has the value 8.23, and I should be able to system.out.println the price. And notice, what would it look like if I printed out just the stuff in? It's going to look the same, right? They'll look the same, but one is a number and one is a string. How could I tell the difference? Well, what happens if I add $3 to this one? Well, it added $3 to it. It's a number. What happens if I add $3 to this one? Well, it didn't add $3. What it did is it added a digit to the string. So it took this string, 8.23456, and then jammed a 3 on the end. It didn't add $3. It added the string value of 3. And then did what's called string addition, or it's called concatenation. And I have some examples of those in the note coming up. So here's another example that works for integers. So I've made a variable called age, and then I've parsed stuff in to age. Now notice what happens if I tried to do this. So no, not there. I don't want the blank one. I want this one. So now if I made an integer called age and tried to parse, age is integer dot parse int, and then stuff in, what's going to happen? Well, is stuff in actually an integer? No, it's not an integer, right? It's well, stuff in is a string. I realize that, but it's not even an integer when I changed it, when I casted it. So I'll probably get an error. Let's just check it out. Bam. Number format exception for input string 8 point blah 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 number format exception. So that means it couldn't do that. But if I change this to, oops, 823,456, it's going to work just fine. And it did some addition there, and it concatenated that number on the end. That worked just fine. So that's a problem we'll deal with soon. This code. So what we're talking about is this is our big problem that we needed to solve, right? We're getting data from a file. It's coming in as strings. We need to change it to integers so we can do calculations on it. But of course, what happens? Can we go the other way? Can we have numbers and change them to strings? And the answer is yes. And why would we want to do that? Well, in just a moment, I will show you. Casting numbers to strings. So the syntax is double dot to string num, where this here, the input is a double. And it's going to change this double to a string. So if this was the string 8.23, it'll actually change it to the string 8.23. And similarly with integers. And so you're thinking, well, why the heck would we want to do that? Because strings are, you can't do any calculations with them, but I'll give you an example. So for instance, an area code. An area code is an integer, isn't it? It's 519 for ours. And our phone number is a string. And if we wanted to add an area code to this phone number, we might want to change the area code to an integer first, so that, the integer area code to a string, so that we can add on the rest of the phone number, right? And so this would actually work. It would put this as a string together with a dash, together with the phone number, and then I'd have the big long phone number, 519-271-9740. Okay? Notes. More notes. And you're typing furiously. Remember, you can pause me and catch up. Double and integer. So these things here, capital D, capital I, are called wrapper classes. You don't have to, not like JZ, not like that. It's wrapper as in wrap around, almost like a present, wrap around. And you don't have to worry, we're not going to talk about that much more. Just that when you see the capital D rather than the little d, it means we're talking about the wrapper class. When we add two strings together, it's called string concatenation. So this add wasn't adding two numbers together. Adding two strings together is called concatenation. And we'll talk more about string handling soon. One other reason that I thought of that we might want to have a string versus a number would be for formatting. And this is back in ready. Here, I'm going to comment out all this junk, by the way. So why would we want a string versus a number, right? Well, remember that at least in our HSA, the numbers gave us the fields that we wanted to put something in, right? So if this would put 123 in a field. Let's make it more obvious, 15. Right? And if it's a number, then it right justifies it, right? So all the numbers would line up. So if I wanted to write a column of numbers, they would all line up on the right, like we would expect them to, like numbers, which is great. But if we wanted them to line up on the left, like they were addresses, say, then we would want them to be strings. So I could go integer dot to string of this. And I'm hoping this will work. I'm using compound statements, which isn't very good style, by the way. But I run that and notice that they're left justified. If I wanted to print off something else on that line, say print them on the same line, then that would leave 15 spaces in there, and this would be left justified rather than right justified. And I know this is using the HSA console, but other spots it's the same thing. Strings behave differently than numbers when we're trying to format them. So that's another reason we might want to change a number to a string. Usually, like in all of our exercises that you're about to do, we are worried about reading in strings and outputting numbers so we can do some calculations. That's normally what we do. We read in data as strings and output them as data, number data. Okay, lovely. One thing that I'm kind of worried about is, well, what happens if, you know, we get something from a file, because that's what you're going to be doing in the exercises, and it reads wrong, and this ends up actually being just like I showed on that one example where I read in 8.23 there and tried to change it to an integer, and it couldn't. It gave me an error and bombed out my program. You know, and this stuff happens, right? You ask somebody for an integer, you ask somebody for an integer, so ask somebody for an integer, some number, and they put in hello. Bombs out your program. Fatal error. Sounds terrible. Well, there's got to be some way to handle this that's a little bit better than crashing your program. And that is coming soon, my friend. That will have to wait until the next day. But now you've got some data casting exercises to do, changing your program that you just wrote for the warm-up, and also some stuff, I think. Say about that? Okay.